Well, it's time for a spectacular Wise Guys Wednesday, everybody.
That's right. Paul Kwiat, mad scientist from the U of I Physics Department, joins us now. We're continuing our lessons about sound.
We are. So today is going to be a great Halloween day.
What's with the not bow tie and suspenders?
Yeah, what's going on?
It's Halloween.
It's Halloween.
Guys, everybody, this is an Einstein tie.
It is an Einstein tie, and that's going to tie into what we're talking about today. Tie in, exactly right.
Got it.
Got that?
Got it.
Today's going to be great. It's going to be spooky. We're going to have a little witchcraft, even chance of death here. So.
Oh, chance of death. All right. Totally on board.
Thanks for Halloween.
Let's check it out.
Yeah, so let's just go way back into the 1800s when people did not actually know that there were atoms. People were not sure that there were atoms. And actually, Einstein made some predictions, and they were verified, and that first convinced people that there were atoms. And so what makes one atom different from another is that they might have different numbers of electrons. Those are the negative charges, different number of protons. Those are the positive, and then neutrons. So if we have something like helium, helium has just 2 neutrons and 2 protons, so it's pretty light.
Okay.
We have something like nitrogen. Nitrogen has 7 protons and 7 neutrons, so it's quite a bit heavy. But we don't normally get atomic nitrogen. We normally get molecular hydrogen, which is 2 of these things together.
Got it.
Okay. Put that on the back burner. We will come back to that.
All right.
Last time, we talked about sound as a pressure wave, and we had this other graphic. If we just put the first of our little graphics up
they're
there.
in there.
You have it.
Okay,
There it
great. Yeah, so we got this pressure wave, and we talked about the fact that the pitch, which is the frequency that you hear, is just given by the speed of the wave over the wavelength.
Got it.
And we talked last time, if we could just go back to regular video here, that the wavelength is often determined by some physical constraints. So, for example, the length of the guitar string or something like that. If I change that, that's a way of changing the pitch. Our vocal cords, the length of those will determine what the pitch that we have is.
Sure.
So today we're going to try and change the pitch a different way. Instead of changing the wavelength, we want to change the speed.
Okay.
Okay.
Okay. And so it turns out that the speed of sound is pretty much closely proportional to the average speed of the molecules in the air that are moving.
Okay.
And it makes sense because if you have a collection, this cluster of atoms, and then they have to exert a pressure, it's, how they collide with the next ones depends on how fast they're moving.
Yeah.
Okay, so now if we go back to the other slide.
Let's go back.
Great, yeah, so it turns out that the kinetic energy of a gas, that's 1/2 times the mass times the velocity squared, the speed squared, is proportional to the temperature. So we're just the temperature of everything in the room is the same, so we're gonna ignore that. So the point is that the velocity, if we just do a little algebra, the velocity goes like 1 over the square root of the mass. And that's the same as the frequency. We said the velocity and the frequency of a wave are the same.
So in English.
In English, if you want to have a higher frequency, what should you do to the mass of the particles?
They need to decrease?
They need to decrease, exactly right. So normally we are breathing in nitrogen, which has these molecule which has 28 protons and neutrons. So you could think of that, here's the 28 protons and neutrons. Yeah, but if instead I were to breathe in helium, helium has only two protons and 2 neutrons, so 4 protons and neutrons. So it's a lot lighter, and so the speed of sound should be higher, about a factor of 2.7 in helium than it is.
So if the speed of sound is a lot faster, therefore the
pitch should be higher.
Oh, are you gonna?
Oh, are you?
I see.
I can get this to open up here.
Okay, so now that I have some helium in my voice, obviously it pushes the pitch up. Yeah, okay, so higher, faster pitch. Okay, so that's not very spooky. On the other end of the spectrum, we could do something instead like sulfur hexafluoride. Hexafluoride. Like a spell, right? Hex is like a spell. Or 6.
Yeah.
So this is sulfur with 6 fluorines around it.
Okay.
And that has a mass of 146 protons and neutrons.
That's huge.
That's very, very much heavier. Yeah, so I'm going to breathe in some of this.
Is that breathable gas?
Are you going to be okay?
Well, I have to just make sure. So with the helium at the end of this, if I just stand up, the helium will go out of my lungs because it'll go up. With this, if I just stay standing up, it'll stay there.
So you got to bend over
and I'll suffocate.
And go.
Got it. Okay,
exactly. Right.
Okay.
But this is about the coolest
I'm glad
demo.
he's doing this.
I am right. I don't think I could do it.
Coolest demo that I know.
Oh.
Oh boy.
Luke, I am your father.
Oh my gosh.
Very spooky, and I'm not trying to lower my voice. I can talk as high as I want, and it still sounds very low. Yes. Okay, so that's good. So I'm gonna first get this out of my lungs.
Oh my gosh, Paul, I did not expect that.
That's a lot better. So you want to do end with our little Three Stooges thing here?
Yeah, let's do that.
Okay.
Oh no, I don't want
No. You were just going to breathe in this. It's just helium.
Just me?
Yep. And I'm going to breathe in this one.
Okay.
You guys ready?
Okay. Hello.
Hello.
Happy Halloween, everyone.
We'll be right back. 3-Minute Grill with Adam Wisniewski is next. We're heading
Coming up.
outside.
Thanks, guys.
Coming up. Oh my God.